Hi DIYers, Sterling with Alarm Grid here, and today we're going to show you how to wire up an iGSMV4G dual path Honeywell AlarmNet communicator to a Vista 20P Honeywell wired alarm control panel. On its own, the Vista 20P, which is Honeywell's flagship panel, by far the most popular panel that Honeywell dealers will install for you, it will only support phone line communication using the incoming phone terminals using a traditional analog phone line. This system is not designed for digital phone service, and all phone companies are transitioning away from analog phones and going to digital phones if it's not done already. Even if you have a true copper analog phone line in your house, the chance that one of the switches on the phone system service side from your house to the central station, one of those switches is going to be digital. As soon as your analog signal hits a digital switch, it's as if you have VoIP phone in your house, and you're going to have all of the same problems that people that use VoIP phones have with alarm signaling. Your signal may not reach the central station at all. Your signal that's supposed to hit to your account can hit to someone else's account. There's all sorts of problems with VoIP phone signaling using a digital phone service. So we always recommend using either an internet, cellular, or dual path alarm communicator that goes through Honeywell's managed AlarmNet servers. The signaling is faster, more reliable, more secure, and gives us a lot more ability to troubleshoot your system when there's issues, know what's going on with your system because it's supervised, and also you have the ability to get Total Connect 2.0 service, which allows you to arm and disarm your system from a smartphone, mobile device, computer. You can receive text and email alerts. You can do Z-Wave home automation control. Total Connect is a very powerful addition to a Vista 20P panel. But you do need an AlarmNet communicator. We're going to show you the iGSMV4G, which is our most popular communicator because it offers you the flexibility to use the speed of the internet path, but also has the security and signal path reliability that cellular communications offers. And what that means is if your internet fails, it has a backup cellular communicator that uses AT&T's cellular network to send the signal out to the servers and to your central station or to the Total Connect service side. So the process to wire the iGSMV4G to the panel is going to be the same if you're using any of the other AlarmNet communicators like the 7847i, which is an internet-only communicator, or the GSMV4G, which is a cellular alarm communicator. It'll be the same wiring. We're going to show you how to do it with our most popular one, the iGSMV4G. So the tools you're going to need your iGSMV4G communicator. You're going to need your Vista 20P control panel. If you want Total Connect service, your Vista 20P will require a prom chip version that is 912 or higher. So there's a black prom chip in the middle of the green circuit board. It'll say WA20P dash a number. You need to have a version 912 or higher if you want Total Connect 2.0. We have another video that shows you how there's options to upgrade your prom depending on the version you have now. And if your panel doesn't have a 912 chip, there's a chance you can still get Total Connect service. And in fact, we even offer the iGSMV4G as an iGSMV4G-TC2, which comes with a prom upgrade chip. And again, we have a video that shows you that prom upgrade. In this video, we're just going to show you the wiring of the communicator to the panel. Once you have those two items and you verified you have the right prom version, then we're also going to need the transformer that comes with the iGSMV4G. This is a two-prong plug-in power supply that plugs into a standard wall outlet and provides power to the communicator. The communicator also has a sealed lead acid battery backup so that if you lose power to this unit, whether it's damage to this unit, damage to the wire of this unit to here, or just a simple power outage or a power outlet issue, this communicator will still work because of the battery backup. Same idea. Every alarm system is powered by a transformer, and if the transformer gets unplugged or there's a power outage, the system has a battery backup. So the important thing is that your communicator will be ready when you need it as long as you're powering it with the right transformer and have the battery backup. In addition to that equipment, You're going to want a good pair of wire strippers. You're going to want a nice little screwdriver which will fit the terminal screws both on the panel and the communicator that we're going to use to land the wiring to. And we, of course, need some wire. We have 22 gauge 4 conductor wire, or commonly called 22-4. This is solid core wire, although you can certainly use stranded wire as well. Sometimes that's easier to work with. It doesn't really matter. It doesn't have to be shielded or anything fancier than that. So 22 is the gauge, or the thickness of the conductors, not the thickness of the white sheath. It's the thickness of the conductor on the inside. And when we talk about conductor, it's how many little wires are within the white sheath. So in this case, 22-4 is 4 conductor. We have 4 different colors, 4 different wires that we can use to connect the communicator to the panel. So now that we know what we need for this project, we're going to show you how to complete this project. So your Vista 20P panel, as we discussed, is powered by its own plug-in power supply, which is just a 2-prong transformer, plugs into a standard wall outlet. The most common one you'll find on a Vista 20P is a 1321 Honeywell transformer, which is a 120 volt input, meaning a standard 120 volt outlet, and it outputs 16.5 VAC, 25 VA. So that's the rating of this transformer, and that's the rating that's needed for a 20P. The iGSMV4G comes with a 1361 transformer from Honeywell, which is the same 120 volt input from the regular standard wall outlet, and it's also 16.5 VAC output, but it is a 40 VA, so it's a higher voltage rating to give more power. What you can do, oftentimes where your panel transformer is plugged in, you may not have an available outlet. So while you normally wire your iGSMV4G and mount it on the wall near your 20P panel, you may not have an available outlet, and that can be a problem for some people. However, the good news is you can simply use a shared transformer. So instead of wiring off your iGSMV4G to this transformer and plugging this into an outlet, if you don't have that spare outlet, then you simply change this 1321 transformer that powers the panel out to the bigger 1361 transformer that comes with the iGSMV4G. Once you do that, you can use this unit to provide power to both systems or both devices in parallel. What that means is you would use the existing wiring from the 20P. On the 20P, the first 2 terminals of the panel are the AC input terminals, power terminals. AC is not polarity conscious, so there's no positive or negative. You simply have a 2-wire connection, 1 and 2, runs through the wall, and comes out wherever this is plugged into the wall. You have 2 screw terminals on the back of the transformer that you'll see once you unplug it. And if you were to disconnect these two terminals by simply unscrewing them, you would of course want to make sure you've removed this from the outlet and also disconnected a lead from your backup battery on your panel. So now you have your panel fully powered down, and you can disconnect the existing wiring, which is no longer live, to the 1321, the smaller transformer. And on the back of the 1361, you have the same 2 screws. Again, it's AC power, so there's no positive or negative. There's no polarity. You simply land 1 to one and 1 to the other. Honeywell now sells the 1361 as a 1361-T. And that would have a 3rd screw, but you don't have to worry about that middle screw. That's just a grounding screw. I'm sorry, 1361-GT as in grounding terminal. And again, that would be in the middle. A lot of people get confused and think they go AC to GT, the grounding terminal. You don't. You just do the 2 AC terminals. So we're using the existing wiring that's run through the wall. Oop. You want to make sure you screw it down nice and tight so the wire doesn't come loose like it just did to me. you'll find often that the wire that's already landed to the old terminal has a nice little fish hook on the end so that you can wrap it around the screw terminal and make a really good contact so that you don't have any loose connection or bad connection. All right, now we have a nice tight connection on both terminals, and we now have a transformer which will work just fine to power the 20P, and more importantly has enough VA rating that we can run a 2-wire connection off of 1 and 2 on the panel and land it on terminals 1 and 2 on the iGSMV. And again, we've now eliminated the need for a second outlet to be near where we're going to install this unit, because we're using the one transformer to run power to here, and then we have our 1 and 2 connection off of here, going to 1 and 2 on here, and the 1361 powers both units, and it is a approved wiring setup when using the iGSMV4G. If you happen to have the other outlet, it's even easier. Just run 1 and 2 off of here to the 1361 and leave the panel power alone. So, now that we've reviewed the different ways to run power to these units, I'm going to swap my panel and my communicator so you have a nice view of both. And we're going to detail the wiring that goes between the two and the wiring to the transformer. So, we're going to cut a length of wire off of our spool of 22/4. And depending on where you're mounting this, most people just mount it right to the side of the panel, so you don't need very long wire, but you simply cut a length for how long you need between the two devices, and you strip off the outer sheath using your wire strippers. You have your 4 conductors, and again you're going to have to strip the ends of each conductor. This is 22 gauge. And on the other end, we already had stripped the sheath to explain what 22/4 is, but we do need to strip each conductor. And now we have nice clean ends on both sides, 4 conductor each. This wire is traditional color, which is black, red, yellow, and green. If you have wire that has different color, it doesn't matter. Don't get hung up on the color. It's all about which terminal on here is going to which terminal on here. We're of course going to show you the proper convention for the color, but again, it really doesn't matter. If your wire is a different color, it's still going to work. So even though we're getting power to this and to this off the transformer, there's still a power connection from here to the panel's power output. And that starts on terminal number 3 on the iGSMV4G. I'm going to turn my unit here so you can see the numbers of the screw terminals and follow along with what I'm doing here. So terminal number 3 on the iGSMV4G goes to terminal number 5, counting from the left, on the 20P. And that is your positive power output. So the panel gets power input from the transformer, 16.5 volts, and pushes out 12 volts on terminal 5, and the ground, or the negative output for that 12 volt power output, is number 4. And that's what we're going to connect first, is those power connections. So we land our red wire, or our positive wire, to terminal 3. On this terminal block, I'm going to show you how this works. There's screws on the back side here, and on the front side you can see there's a gap on all the ones I haven't wired yet. That gap means it's open. The terminal block is open. You can fit your wire in, and then on the top side you screw it down and it closes the terminal connection to keep your wire tight. So those terminals are what they use on the iGSMV4G. On the 20P, it's more of just a simple screw with a contact underneath, and you just loosen the screw enough that you can fit your wire underneath. Making sure that you're not extending your exposed wire too far where it can jump over and touch any of the other terminals. They do have these black blocks to prevent that type of thing, but depending on how long you strip your wire, we have seen people where it gets a little messy in there, so you don't want to go too far or too big on this portion of the wire. Also, we have a nice clean panel here. When you're adding this to your system, you're going to have a lot of things wired on here. If you have keypads, they're wired here. If you have wireless receivers, they're wired here. If you have 4-wire motion detectors or glass break detectors or smoke detectors, they're going to be wired here. So don't get confused by that. All you simply do is land multiple wires under the same screw terminal, making sure that you don't let any of the existing wires fall out. If they do fall out, make sure they go right back to the same terminal they were on. So again, you can land multiple wires under one screw on this panel. As long as the wire connection on your wire is making contact to the metal screw, you're good to go. So again, we have terminal 3 on the iGSMV4G to terminal 5 on the Vista 20P. Now we go to the next one. On terminal 4 is our black wire. We insert the wire to the open terminal block. Make sure it's in there. I know we're blocking the view right now, but just to make sure it doesn't fall out, you get it nice and tight on the top. Give a little tug to make sure it's not loose. You don't want these wires falling out. You're going to have issues with supervision of this unit to here. And on this side, 4 goes to 4. So again, you're going to have other things landed on 4 here. You just loosen the screw enough to be able to fit your black wire and land it to 4. That is your power connection, so that if you did lose power from the transformer, the Vista 20P is still feeding power over to this unit to keep it held up. So now we need our data connection. Data is data in and data out, and that's our green and our yellow wires. So we're going to do terminal number 5 on the iGSMV4G is the yellow wire. Feed the wire into the opening. Screw it down tight. Make sure you give a little tug, it doesn't fall out. 5 on the iGSMV4G goes to 7 on the 20P. When we talk about data in and out, we're talking about a device that needs to be able to pass data to the panel and vice versa. So when the panel has an alarm signal, it needs to pass that data to the communicator so it can send its signal to Honeywell servers for central station and or Total Connect service. So that's why we need 4 connections, power and data. So we've got 5 to 7 data, and now we have 6 on the iGSMV4G. Goes to 6 on the 20P, which is our last keypad bus terminal that is not used. Open up the screw terminal to fit the green wire under. Make sure we're not loosening any other connections that might already be present there. Screw it down. So now we're fully connected wire to wire. In this case, you would want to have run the wire through a knockout on the control panel so that when you close your panel lid, you're not crimping this wire. I failed to do that here, but they have multiple knockouts that you can use on this 20P cabinet. There's one here, there's some on the top. And so you can kind of pry those out and feed your wire through there so that when you close your cover, you're not going to be pinching this wire. The important thing is you get your connections mapped properly. So with those connected, we can now address the power connections to the iGSMV4G. We don't want the panel feeding power to here all the time. We want the transformer to be feeding power to here, and the panel's only here as a backup when you lose power to the transformer. And again, you would have wanted to feed these wires through this back hole on the iGSMV4G, or try to notch the plastic out here. There's a little tab that you can notch out so that when you have the cover on the iGSMV4G, you're not pinching this wiring. So we're going to need another length of wire. If you get a length of 22.4, just make sure you have enough for this connection and then enough for another connection from here to your transformer, however far that may be. If you're doing the separate transformer. If you're doing the shared transformer that we discussed, then you don't have to run to the transformer because the transformer is already feeding power to the 20P, and you're just making your 1 and 2 connection on the iGSMV4G to 1 and 2 on the panel. So that bigger 1361 transformer is powering both units in parallel. So we're just going to cut another similar length of wire. We strip our white sheath off to expose the internal conductors. And just for convention, we can use black and red, which is normally used for power. You could even double these wires up if you were using skinnier 22 gauge wire. Oftentimes you'd want to use probably 18 gauge wire when running direct to your transformer power wire. You want to be a little bit thicker depending on your wire run. In this case, with such a short run, 22 is fine. I'm just going to trim back the green and the yellow conductors and just use the black and the red. So we strip the ends. And we have our connection that we can land here. Strip the other end. Trim back the green and the yellow. Strip the red and the black. And we now have our wire ready to connect from 1 and 2 on the 20P to 1 and 2 on the iGSMV4G. This is AC power again, no polarity. There's no positive or negative. You simply land each one and make sure to screw it down tight. Oop. And you want to tug on the wire after screwing. You want to make sure it's not coming out. You don't have to pull too hard, but just give a nice little tug to make sure it's not loose. And you put your black into the other terminal that you did. In this case, we did black on 2, or red on 2 and black on 1. You could have done the opposite. It would work the same. You would feed your wiring through the wire channel that you knock out here, or through the back if you've got a hole that you can run through the wall. You would either come in through the back of here. There's knockouts in the 20P. There's knockouts along the 20P, and you feed it in to the panel. To keep things consistent, we can certainly put red to red and black to black. It doesn't matter. You could swap it. AC power, no polarity. Last connection. Tighten it down. Give a nice little tug. Make sure nothing, and lo and behold, this one came out on my tug. So we're going to make sure that one gets down nice and tight. We would never want that to fall out on its own, especially because once we plug that transformer in, that's a live wire. You would never want that to fall out and touch anything else on this board, potentially do damage to the board. So now we have our ECP connection, data and power, 3 to 5, 4 to 4, 5 to 7, and 6 to 6. And we have our power run shared transformer, 1 and 2 to 1 and 2, and then 1 and 2 to the 1361 transformer. And that is all of the connections that we need. At this point, we can plug our battery leads back in. We've got our one red connection disconnected to keep the unit fully powered down. You'll notice that on the iGSMV4G, it will power up off the battery only. So as soon as I'm touching this lead to the terminal, we're seeing light activity on the board. So this will power up off its battery only. Whereas on the 20P, when you connect your battery, it's still not powered until you plug your transformer back into your standard wall outlet. So the last step is plug this in. You'll often see there's a screw, which we just have removed right now, that if you remove the screw in the center of your 2 outlet wall plate, you can screw it through here into your wall plate to hold the wall plate to the outlet so that this doesn't get unplugged accidentally. If someone sees this screwed into the outlet, they're never going to unplug this. That's because this is critical. You don't want this getting unplugged because you don't want your panel or your communicator to lose power once the battery's drained. You don't want your cleaning lady to say, oh, I need an available outlet for my vacuum cleaner, I'm just going to unplug this for a little while. That screw prevents someone from accidentally unplugging this, not realizing what it's doing. So now that you've got this connected, we've got our proper prom, we now have a system that can be monitored either internet, cellular, or dual path. It can do central station service and or Total Connect 2.0 service, and with the right monitoring service, you're all set up. So if you have any questions on wiring up any of the AlarmNet communicators, whether it's the iGSMV4G, the 7847i, the GSMV4G to your Vista 20P, Vista 15P panel, please email support@alarmgrid.com. If you enjoyed this video, please hit like below and make sure to subscribe to our channel.